Okay. Online all okay? Okay. So basically today we are going to have the first session on science and technology. And today it's just a normal class. I mean, like, we are going to discuss some of the fundamental aspects related to science and technology. And today we want to discuss about physics and chemistry related topics. What topics? Physics and chemistry. As we all know that science and technology has a weightage of about 10 to 15 questions in the prelims exam. And we are studying science and technology from the prelims point of view at this point of time. So we need to understand those topics from the viewpoint of the prelims exam only. Okay. So maybe tomorrow I will come up with the analysis of the previous year, let's say, questions in science and technology from various areas. But today we want to start the discussion with the topics itself. Okay. So let us discuss about, let's say, science and technology. When we talk about science and technology, what do we mean by this? It means studying science and also applications of science. Application of science is technology basically. Application of basic sciences. What is basic sciences? The field of biology, the field of chemistry, field of physics, they are considered to be basic sciences. And everything that we make using the basic sciences is the application part of it, which is technology aspect of it. In the prelims exam, basically UPSC asks question from the basic sciences also, means they ask questions from the physics, from chemistry, from biology portion. They also ask questions from the technological part. But when they ask questions from the technological part, they ask questions from the application of those technologies, where they are, let's say, like, where they can be applied. So the answers to those questions is pretty simple, provided that you are reading the basic sciences, you are reading the technology part, and also you are updated with the current affairs. So it is important that you read the basic part of the science and technology, you read the technology part of science and technology, and you read the current affairs related to it. Okay. So before we start the class, can anyone tell me what is the atomic number of hydrogen? What is the mass number of hydrogen? Why it is the case? There is only one electron. Okay. Online also people are answering to this question. They are saying the atomic number is 1, mass number is 2. They are saying that way. Okay. So like, you know, it needs, like, it is important for us to understand clearly about these things. Many a times what happens, like, we stay confused, and when we see the question, since our basic understanding is not clear, we tend to do mistake in the questions. So we are going to start with that part, and then we are going to build upon it. Okay. So quickly we are going to cover many topics. All right. So first topic that we are going to discuss is atoms and its structure. What? Atoms and its structure. So to understand this particular topic, atoms and its structure, we need to understand what are atoms. Atoms are fundamental building blocks of matter. Anything that we see in the universe, all the different types of matters, whether they are gas, they are solids, they are liquids, everything is made up of atoms. Okay, atoms are, let's say, like, the fundamental building blocks of matters. Okay, that's the thing. When we talk about the structure of an atom, right? So to understand the structure of an atom, we need to understand that atoms are represented. Let's consider we are representing atom with this particular symbol. Okay, let me use this. Let's consider X is atom, and here what happens? There is something which is known as Z. Okay, Z is the atomic number. What? Z is the atomic number. A is the mass number of an atom. What is Z? Z is number of protons. Okay, number of protons. And when we talk about A is number of protons plus number of neutrons. Okay, number of protons and number of neutrons. Okay. So A is mass number. Okay, A is known as mass number, and Z is atomic number. So when we see the structure of an atom, right? Let me draw the structure of an atom for you. Let's consider this is an atom. Inside this atom, we have a central portion, and this central portion of the atom is known as nucleus. Okay, this is known as nucleus of the atom, and this is the overall structure of the atom. Inside the nucleus, which particles are present? So inside the nucleus we find two particles. Number one is protons and number two is neutrons. Okay, inside the atom we find protons and neutrons. So can anyone tell me why only protons are not there inside the nucleus? What is the role of neutron inside the nucleus? What is the role of neutron inside the nucleus of an atom? Basically what happens, we all know that similar charges repel one another. Protons have positive charge, neutrons have zero charge, right? So inside the nucleus of an atom, we have huge number of protons. It depends, let's say, how many protons we have. Accordingly, we give them name to that element. We give them name to that atom. So number of protons determine what is the atomic number of that element. And based on the atomic number, we have given names to each atom. For example, hydrogen has one proton, it is called hydrogen. Anything that has two atoms, it is known as, anything that has atomic number 2, it is known as helium. Anything that has atomic number 3 is known as lithium. Atomic number 4, beryllium. 5, boron. So basically all these elements are there in the periodic table of elements. Okay, all these elements are found in the periodic table of elements. Are we understanding this part? So basically when we talk about atoms, right, inside the atom, inside the nucleus of the atom, we have the protons and we have neutrons. What is the role of a neutron? Basically what happens, all protons that are there, they are repelling one another with some force. Why? Because those charges that have similar, let's say, value, positive charge. So two positive charges will be repelling one another, two negative charges will be repelling one another. If we have charges of opposite nature, positive or negative, they will be attracting one another. Generally, when we have neutrons inside the nucleus of an atom, it actually reduces that particular repulsion force. It stabilizes the nucleus of an atom. What it does? It stabilizes the nucleus of an atom. So here protons, number of protons will give us atomic number, number of neutrons will give us mass number. In general, it is not the real case, it is not applicable to all the cases, but in general, the mass number is approximately double the atomic number. What? Mass number is approximately double the atomic number. When we talk about lithium, its atomic number is 3. Mass number is 6, because inside the lithium we have 3 protons and 3 neutrons, right? So atomic number is 3, mass number is 6, right? In beryllium, atomic number is 4, mass number is 8, like that. But in case of hydrogen, when we talk about in case of hydrogen, inside hydrogen we have only 1 proton, we do not have neutron. So that's why hydrogen is treated separately in the periodic table. We have a periodic table, hydrogen separately treated separately. It just has 1 proton, it does not have any neutron. Okay, but now the question arises that what is the role of electrons? So when we talk about electrons in an atom, right? So electrons orbit an atom around, let's say, specific orbits, and these orbits are known as shells. What? These orbits are known as shells. And these shells, basically there is a formula also, there is a rule which is known as Aufbau principle. If you read NCERT books, you will get to know there is a principle, Aufbau principle. So it says that in which cell how many atoms can be there. What? How many atoms can be there. So when we talk about the innermost shell, right? Innermost shell means just the shell just outside the nucleus. This shell will be having the least amount of energy. As we go, let's say, away from the nucleus, let's say I am going to the second shell. So the energy that is there on the electron, in the electron, that energy will be at a higher level as compared to the energy in the lower shell. So the shell which is very close to the nucleus, it has very less energy. The shell in which, let's say, electrons are located far away from the nucleus, they have higher energy. So they are already at a higher energy. If you have to extract an electron, you just give some heat, pass some energy, so like that electron will be coming out like that. Okay. So this is the thing. Basically, like when you read about atom, you will get to know that there are principles that have stated that, like, you know, in the let's say the shell which is inside, I mean like just outside the nucleus, it will be having only how many electrons? 2 electrons. In the second shell, how many electrons will be having? 8. In the third shell? 18. In the fourth shell? So how does it come? How does it come? So number of electrons in a shell is given by, you are saying 2n square. If value of n is equal to 1, what will happen? So this shell is called K shell. So we will be having 2. If n is equal to 2, number will be 2 square is 4 into 2. Like this is, let's say, L shell. So second shell it will be having 8. If n is equal to 3, if you put n equal to 3 in this formula, so this will be equal to 2 into 3 square, which is 2 into 9 is equal to 18. So number of electrons in a shell is predetermined, that in this shell there will be this number of electron. More than this electron may be there, but that will not be stable. That will not make a stable atom. And if we have less number of electron in a shell, let's say as compared to what is required, in that case also it will be unstable. For example, let's consider we have helium. Helium has atomic number 2, mass number 4. What it means? It has 2 protons and it has 2 protons, 2 neutrons, like that. Okay. So the thing is, its outer shell has only 2 electrons. So it will be stable. However, if I talk about, let's say, chlorine, what is the atomic number of chlorine? If anyone remembers, atomic number of chlorine is 17. What it means? That if I have to draw, let's say, like if I have chlorine, the innermost shell will be having 2 electrons. The second shell will be having 8. 1, 2, 3, 4, 5, 6, 7, 8. And this particular shell, it will be having 7. It can have up to 18, but the thing is, there is a rule which is known as octet rule. According to octet rule, any shell which is just outside the K shell, innermost shell, it should have at least 8 electrons to be stable, right? So the thing is, this will be having 7. 1, 2, 3, 4, 5, 6, 7. So the thing is, it is devoid of 1 electron. Means I am just writing X to showcase that there is 1 electron is lacking over here. If 1 electron is lacking, so if it it is unstable. If it wants to acquire stability, what it has to do? It has to either donate 7 electrons or gain 1 electron from outside. What it has to do? Donate 7 or gain 1. So the thing is, what will be easier for it? To gain 1. Okay, so like, you know, they will try to be stable with least amount of energy exchange. That's the thing. So it will try to gain 1. So that's why chlorine, which is in gaseous form, it stays in this particular format, Cl minus 1. Means minus 1 means an electron is coming from outside. It has gained an electron from outside to become stable. Is it understood? This is the thing. Now let us talk about another important parameter, another important thing is that we are going to discuss about an important thing which are known as isotopes. What? Isotopes. What are isotopes basically? Isotopes are those elements that have the same atomic number but they have different mass number. Okay. Isotopes are elements that have same atomic number, I'm just writing this way, but different mass number. What do we mean by this? Basically, we might have heard about this carbon 12, okay, carbon 12 or carbon 14, like that. People write it this way. Carbon 12, carbon 14. What do we mean by carbon 12 or carbon 14? Basically, these are isotopes of carbon. When we talk about name carbon, carbon is given, carbon is name of an element that has atomic number 6. So in carbon, basically in carbon, what happens? We have number of proton is 6, and in this particular case, when we talk about carbon 14, right? In this case, C14, it has number of C12, number of neutrons to be 6. But if we talk about carbon 14, what do we mean by this? In carbon 14, what happens? Number of proton will be 6. Since we are giving it name carbon, it means it has atomic number 6. But let's say it has number of proton will be, number of neutron will be 8. Okay. So these are isotopes of one another. What? These are isotopes of one another. Carbon 12 and carbon 14. Similarly, we have isotopes of many other elements. Okay. For example, when we talk about uranium 233, or let's say I talk about uranium 235 or uranium 238, what? These are same elements, uranium. All of these have same atomic number. But when we refer to carbon 12, carbon 14, carbon signifies what is the atomic number. 12, 14 signifies what is the mass number. What? When we talk about U233, 233 is the mass number of this element. Mass number is sum of number of protons and number of electrons. Here again, number of proton plus number of electron is 235. Number of proton, number of electron 238, like that. So, sorry, number of proton and number of neutron. Okay, proton and neutron. This is the thing. So, number of proton and neutron, their sum is 233, 235, 238. But number of proton is same. These are isotopes of the same element. What? These are isotopes of the same element. This is the thing. So here, now what is the atomic number of uranium? Can anyone tell me?
116, 16, 600.
Yes, anyone who can tell me what is atomic number of uranium?
12.
Atomic number of uranium. Many people are saying 92. 92. Uranium 92. Let me cross check. We have uranium, plutonium, lot of, let's say like we are going to discuss about lot of materials. Okay, it's not here. Let me quickly showcase a periodic table to you. Okay. Let me showcase a periodic table to you. Okay. I think that is okay. I'll showcase a periodic table to you so that like it becomes clear to all of us. This is the periodic table of elements. What? This is important for studying chemistry, because chemistry is all about learning what? Elements, their compounds and all. So can anyone locate where is uranium located? 92. This is uranium. So uranium is a element which is used in all nuclear power plants that we operate in India. We use uranium 235. Which one? Uranium 235 we use. Okay. But naturally which uranium is found? Uranium 238 is naturally found. And the uranium which is naturally found, it is known as a fertile material. What? Fertile. We convert it into a fissile material by doing enrichment. What? We do like nuclear enrichment, or like enrichment of uranium to make it fissile material, and after then we use it in nuclear power plants. Okay, this is the thing. So apart from uranium, plutonium is also used in nuclear power plants. What is the atomic number of plutonium? 94. Atomic number of plutonium is 94. And what is mass number of plutonium? It is 239. I'm going to discuss about it. Its mass number is 239. Plutonium, whenever you hear about plutonium, they say plutonium 239, not say plutonium 94. Name itself signifies what is its atomic number. When we talk about that, this is this number, plutonium 239, it is referring to mass number. This is like, number of protons plus number of neutrons. Okay, this is the thing. And here, thorium. Can anyone tell me where is thorium located? Thorium has atomic number 90. So basically in India, we have a 3-stage nuclear power program. What program? 3-stage nuclear power program. And that 3-stage nuclear power program in India has been initially, let's say, visualized or initially proposed by Dr. Homi Jahangir Bhabha. And after then, let's say that point of time, Jawaharlal Nehru was the Prime Minister. He has accepted it, adopted it. And under the, let's say like India's 3-stage nuclear power program, initially we started with operating nuclear power plants that were working on, let's say like, pressurized heavy water reactors. What? Pressurized heavy water reactors. In those reactors, uranium was used as a fuel. It is still used as a fuel. So far, since independence till now, let's say stage 1 is working in India. For stage 2, recently the Prime Minister of India has gone and inaugurated what? The core loading. Core loading means there is a nuclear power plant. In that nuclear power plant, the core is somewhere where nuclear reactions happen. So there they have installed that facility in the core. Means this power plant is not operational in itself as of now. The core has been installed in that thing. So it was recently, let's say like installed in India. Means like, Prime Minister of India has recently inaugurated this particular thing. That's known as core loading. Okay. So this marks, once this operator becomes, this nuclear power facility becomes operational, then second stage of nuclear power program will start. And what is the difference between first stage and second stage? Basically, when we talk about the first stage of nuclear power program in India, when we talk about first stage, there we were using uranium-235, this one, as a nuclear fuel. What? We used this as nuclear fuel in uranium-235 at that point of time. And still we are using. But the thing is like we do not have huge reserves of uranium in India. What we are doing? We are importing uranium from outside. What is our plan? Our plan is to become self-dependent or self-reliant when it comes to nuclear programs in India. Self-reliant. How we can become self-reliant? If we are using a fuel which is available in India. Which fuel do we have in India? Thorium. But establishing thorium reactors is very difficult because converting thorium into fissile material is very, very difficult. So when we talk about the second stage of India's nuclear power program, in first stage we used this fuel which is imported. In second stage, basically let's say like this fuel, when we use this particular fuel, it also generates a byproduct. What it generates? It generates a byproduct which is known as plutonium-239. Right? This byproduct is not used, it is although generated, but it is not consumed in this nuclear power plant. So it remains, let's say like, it remains waste, or it remains, let's say like a fuel which is separated from the nuclear power plant. In the second stage, what we want to do, we want to utilize plutonium, right? So when we talk about prototype fast breeder reactor, the reactor that was inaugurated by the Prime Minister of India, it is known as prototype fast breeder reactor. This prototype fast breeder reactor will be using plutonium as a fuel. So the thing is, all the fuels that are available with us from these power plants that we have already operated, they will be utilized in this prototype fast breeder reactor. So inside the prototype fast breeder reactor, we give a mix, like mixture of uranium and plutonium is given. So the uranium that is given, it is inside the reactor. it converts that uranium 238 into plutonium 239. Uranium is a fertile material, plutonium is a fissile material. So the thing is, we also give plutonium as an input there, but like we are giving, let's say, 10 units of plutonium, 90 units of uranium, and inside the reactor that uranium will be converted into plutonium. That is known as breeding. What? This process is known as breeding. Breeding means converting fertile material into fissile material. So in prototype fast breeder reactors, breeding happens, and because breeding happens, so it generates more fissile material than it consumes. And this is a very important topic for the prelims exam. Trust me. Apart from this, what happens? Recently in Gujarat, we have operationalized another nuclear power plant. Okay, we have operationalized another nuclear power plant in India. This is the thing. So we will discuss about that thing at a later stage, but here we need to understand what do we mean by atomic number, what do we mean by mass number. We have discussed about isotopes. What are isotopes? Isotopes are different variants of the same element. It means carbon 12, carbon 14, but they have a different mass number. Same atomic number, different mass number. Number of neutron is changing. So now we are going to discuss about another concept which is known as what? Isobars. What? Isobars. Can anyone tell me what is isobar? Definition. So isobars are elements that have same mass number but different atomic number. What? But different atomic number. Isobars are those elements that have same mass number but different atomic number. Can anyone give me an example of isobar? Yes, example of isobar. For example, when we talk about nitrogen, it has an atomic number of 7, mass number of 14. So nitrogen has an atomic number 7, mass number 14. When we talk about isobar of nitrogen, it will be carbon 14. What happened? Here in nitrogen, number of proton is 7, number of neutron, N means neutron, okay, is 7. In carbon 14, what happens? Number of proton is 6, number of neutron is 8. So it is not needed that either their atomic number of proton is same or neutron is same. Total sum should be same. What? Total sum. Total sum is neutron plus proton, proton plus neutron, 14, proton plus neutron 14. They are isobars. So basically when we go back to the structure of the atom once again, this was the structure of the atom. So inside the atom we had a nucleus. Inside nucleus what we had? We had, let's say, number 1, we had protons and we had neutrons also. What? Protons and neutrons. They together, protons and neutrons, they together are given a name. What is that name? Protons and neutrons together, right? So when we talk about protons plus neutrons, whatever we find inside the nucleus, these are known as nucleons. What? Nucleons. Nucleon is a common word for proton or neutron. Nucleon is a common word for proton or neutron. Okay, this is the thing. So they are known as nucleons. So the thing is, number of nucleons must be same. What? Number of nucleons must be same. This is the thing. So this is known as, yes. Yes. Like isobars mein kya hai? Number of nucleons must be same. But we are talking about in general. There is an atom. Inside the atom we have what? We have the nucleus. and whatever is there inside the nucleus, means like proton plus neutron, they will be together known as nucleons. This is the thing. When we talk about isobars, basically number of nucleons must be same, right? Number of nucleons must be same. This is the thing. So this is related to an atom. Now let us discuss about hydrogen. What? Let us discuss about hydrogen. Okay. Hydrogen is represented by the symbol H, right? It has atomic number 1, mass number 1. What it means? Number of protons that it has 1 and number of neutrons that it has 0. Okay, so proton will be 1, neutron will be 0. This is known as hydrogen. Since hydrogen does not have any neutron in it, so that's why it is kept separate in the periodic table. Top में है, अलग से है, ठीक है? It is represented differently also. In some periodic table, it is represented, let's say maybe in the middle, like that. Okay, it has. This is the only element that do not have a neutron. ठीक है? That do not have a neutron. All other elements have neutron in it. Okay, this is the thing. All other elements does have a neutron in it. Now we need to understand one thing. Let's consider we do have atoms, right? So can the number of protons and neutrons change in an atom? Anyone? Yes.
And if we remove that, the atom will not remain that particular atom.
Okay, okay. See, basically what happens, I'll come to that point. We will discuss in detail about that concept also. But here we are discussing about hydrogen. Hydrogen has 0 neutron, 1 proton. Now let us understand about this thing. Once again, we come back to this topic, which is atom. Inside the atom, we have a nucleus, right? Inside the atom, we have a nucleus. And inside nucleus, we have protons and we have neutrons. When we talk about protons, right? Whatever is the mass of a proton, that mass is considered to be a, let's say, like, measure of unit when we discuss about atomic mass. So when we talk about proton, right? When we talk about proton, the mass of a proton, okay? Mass of a proton, right? Mass of a proton is considered to be 1 atomic mass unit. What? 1 AMU. Whatever is the mass of a proton, it is 1 atomic mass unit. Apart from this, when we talk about what is the charge in a proton, this is plus 1.6 into 10 raised to power minus 19 coulomb. This is the charge on a proton. Similarly, when we talk about a neutron, when we talk about neutron, number 1, what is the mass of a neutron? This is equal to 1 atomic mass unit, because mass of a proton is approximately same as that of mass of a neutron. Mass of a proton is same as mass of a neutron. When we talk about what is the charge in a neutron, okay, charge. So charge is equal to 0. What? How neutron varies from a proton is because of the charge that it has. So neutron does not have any charge, proton has a charge in it. Otherwise they have mass same. When we talk about an electron, so outside the nucleus, what is happening? Electrons are revolving, right? Electrons are revolving. When we talk about mass of an electron, let's say I'm writing electron here. Right? what is the mass in an electron? Mass of an electron, I'm just writing this way. Mass of an electron. Mass is never negative. Mass is either 0 or positive. Mass is a quantity which is either 0 or positive. This is 1 by 1836 of atomic mass unit. Means whatever is the mass of a proton, we need these many electrons. I mean like 1836 electron will be equal to mass of a proton. What? No formula. It is like mass of an electron is very less as compared to mass of a proton. मान लेते हैं, I have two things, this one and this one. I am saying its mass is 1 unit, and if I have 10 of this particular thing, its mass will be equal to this. 10 mass equal to this, right? 1 mass of it will be this way. So mass of 1836 electrons is equal to mass of a proton. It's like that. I am not writing exact mass, that is known as atomic mass unit, that you can anyhow find out. Something into raised to power minus 31 kg. Means like some value into minus 10 raised to power minus 31 kg. It's like when we talk about mass of a proton, some value into 10 raised to power minus 31 kg. It is like that. Very small. It is not negative. When we write 10 raised to power minus 31, it means 1 upon 10 raised to power 31. Okay, this is the thing. So is it understood? Mass of an electron is this. When we talk about what is the charge on an electron, charge on an electron, right? It is minus 1.6, this is point, into 10 raised to power minus 19 coulomb. This is charge on an electron. When we calculate the mass of an atom, what we do? We do not take into account mass of an electron. Why? It is because as compared to the mass of a proton, for example, if we see the periodic table, which element in this periodic table do you think has the highest atomic number? Which element? In this 103 only, means like there is no, let's say like no atom as of now that may be having 1836 electrons. Are you understanding? To make up one value, 1 unit of proton, whatever is the mass of a proton, we need 1836 electrons to be equivalent to mass of 1 proton. So that's why mass of an electron is negligible. So whenever we calculate the mass of a atom, we generally do not take into account mass of a what? Mass of the electron. This is the reason. I mean like its mass is negligible as compared to overall mass. This is the thing. Now here we are going to discuss about some important things. What important things is that let's say I asked a question to you that can the atomic number or mass number of elements change? Yes, they definitely change. And how do they change? They change because of radioactive decay. We are going to discuss about radioactive decay. What do we mean by radioactive decay? We do have different types of radioactive decay. We have alpha decay, beta decay, gamma decay, etc. Right? So we are going to go into that part. So now let us understand about that thing. What? Next topic which is associated with this is radioactive decay. What? Radioactive decay. What do we mean by radioactive decay? I'll make you understand. First one is known as alpha decay. What? It is known as alpha decay. What do we mean by alpha decay? Basically, let's consider there is an element. This is an element, this is an atom, any atom from the periodic table, okay, that has, let's say, I'll discuss about this. From this atom, let's say, alpha decay happened. Alpha decay happened, right? After then, it will convert into another element. What? It will convert into another element. But when we talk about alpha decay that happens, alpha decay means some atom has come out that has number of protons 2, number of neutrons 2. What do we mean by this? Alpha decay means an alpha particle has come out of it. An alpha particle has come out of it. An alpha particle has 2 protons, 2 neutrons. Any element in the periodic table that you see having 2 protons, 2 neutrons? Helium. When alpha decay happens, it is equivalent to that a helium has come out of this atom. What? A helium has come out of this atom. So let's consider this was an X atom. I'm giving an example. This is an X atom having atomic number 90, mass number 235. Let's say 92. Okay, 90 के जगह पे let's take this example. Atomic number 92, mass number 235. Right? From here, if alpha decay happens, what? If alpha decay happens, what will happen? Helium will come out of it. Helium means 2 atomic number, 4 mass number. 4 mass number means 2 plus 2. It has come out of this. Since this thing has come out of this element will convert into another element Y, and this element will have Z minus 2 and A minus 4. Z minus 2, A minus 4. What is Z? Z is the atomic number, right? A is the mass number. So Z minus 2 means like this Y will be equal to Y90, right? And this is 231. Are you understanding? This is known as alpha decay. So whenever alpha decay happens, and how alpha decay can happen, now we will discuss about it. Okay, means like it is not an example of alpha decay, but when we talk about nuclear reactors, all the nuclear reactors that we are operating in the world, in those nuclear reactors, one type of nuclear reaction happens that is known as nuclear fission reaction. What? A kind of nuclear reactions happen that is known as nuclear fission reaction. What? Nuclear fission reaction. What happens in nuclear fission reaction? Generally, let's consider I have uranium 235. What? Uranium 235. What I do, I bombard this uranium with 1 neutron. What? 1 neutron. Okay, I bombard this thing with 1 neutron. Means uranium itself is a very big atom. Since it is a big atom, so generally it has little less stability inside it. It is a fissile material. When we bombard it with some kind of neutrons, neutrons have 1 mass, 1 atomic mass unit. It has 0 charge. So if we have a uranium over here, if we are bombarding means on this big ball, we are throwing some small ball like that. What it does, a radioactive reaction happens. Then it gives out 2 elements altogether. Okay, one of the element is barium, other element is let's say some like xenon, I think. Okay, so one is, just a minute, krypton. Okay, one is krypton with this atomic number 36, and it gives us another kind of element. Okay, so this is the thing. So this is known as nuclear fission reaction. Okay, so after nuclear fission reaction happens, it gives us 2 elements. Let's consider X element plus Y element, plus it gives 3 neutrons. What? 3 neutrons. Plus it releases huge amount of energy. What it does? It releases huge amount of energy. That's the thing that happens. So this is not the exact reaction. I'm going to write that reaction for you. I'm going to showcase that reaction also. Are you understanding? So over here what happens? We bombard it with neutrons, and then this neutron breaks this particular uranium atom into 2 different atoms. Okay, so one atom is getting converted into other atom. So atoms can convert from one form to another form, and this is known as nuclear fission reaction. all the nuclear power plants that we have in the world, right, that we presently have in the world, everywhere nuclear fission reaction happens, right? Everywhere nuclear fission reaction happens. Nuclear fusion reaction does not happen. Why it does not happen? We will discuss about it. Okay, this is the thing. So this is known as nuclear fission reaction. Is it understood? Similarly, what will happen? Like in case of alpha decay, did you understand about alpha decay? Now, let us discuss about another kind of decay, which is known as beta decay. Okay, second one is known as beta decay. What do we mean by beta decay? Beta is also represented by this symbol. What this symbol? Beta decay. What do we mean by beta decay? Beta decay happens when one, means like beta decay is of two types. Okay, one is known as beta minus decay, second is known as beta plus decay. Beta plus decay is also known as positron emission. What? Beta plus decay is also known as positron emission. So here let us understand what are beta decay first of all. Beta decay happens, we already discussed that an atom will try to have a stable condition. It will try to have a stable condition. We discussed that whenever the number of electron in the outermost shell is less, in case of chlorine, it will try to attract one more electron from outside so that it becomes stable. So Cl minus 1 is more stable as compared to Cl, because Cl has one deficit electron. So that is in case of electrons. But when we talk about an atom like this, let me draw this atom. This is the atom once again. This is the atom. So here, this is the nucleus. What? This is the nucleus. Inside nucleus, we find two elements. What are they? Protons and number 2, neutrons. Now, as we discussed earlier, what happens, like every charge that has similar charges repel one another. Means like if I have 2 protons, they will repel one another. If I have 2 electrons, they will repel one another. But if I have an electron, if I have a proton, they will attract one another like that. What happens if in case inside the nucleus, if number of protons are very high? What? Numbers of protons are very high. What will happen? It will try to convert. What? It will not try to send that proton out of the nucleus. If the number of proton is very high, it will not send the proton outside the nucleus. What it's going to do, it will convert that proton into a neutron. Proton has positive charge. There will be a positron emission. So when positron emission happens, what is positron? This is important. Electron, we understand what is electron. Positron is an element similar to electron, mass equivalent to electron, but charge is positive. Positron has a charge of plus 1.6 into 10 raised to the power minus 19 coulomb. So what happens when the number of proton inside the nucleus is high? So there will be more repulsion, it will not be stable. And if we, let's say like in place of it, if some protons are converted into neutrons, it will be more stable. So that's why positron emission may happen. That is known as beta plus decay or positron emission.
So how do the protons convert into neutrons inside the nucleus?
So this is known as decay, means like beta plus decay will happen. It happens automatically for all those elements that are radioactive elements. It happens for which elements? Radioactive elements. Those elements that are in themselves not stable.
So proton converts into neutron.
Yes. No, neutron also converts into proton, proton also converts into neutron. We will discuss about it. As of now, we are discussing the case when proton is converting into neutron. Why it is converting? Because inside the nucleus, the number of proton is more, that's leading to an instability. Since it is leading to instability, instead of repelling, sending the proton outside the, let's say, atom, what it does, one proton goes through positron emission. Positron emission means like this, a particle that has positive plus 1.6 into 10 raised to power minus 9, it will come out of it, and then it will be having the same mass. After alpha decay, what happened? After alpha decay, the atomic number reduced by 2, mass number reduced by 4. We discussed, right? But after beta decay, atomic number or mass number do not change. What happens? Atomic number or mass number do not change. So when positron emission happens, what happens? One proton is converted into a neutron. Right, into a neutron through a positron emission. What? Through a positron emission. Is it understood? One proton is converted into a neutron through a positron emission, and after then it becomes stable, more stable as compared to before. It is possible that more number of beta decay happens, means like, one beta decay happened, still it is not stable, then maybe another beta decay can happen. That's the thing. So is it understood? Is this example? Similarly, what happens when we talk about beta decay? Beta decay is the process of conversion of one neutron into one proton, or vice versa, right? Why neutron gets converted into proton? Basically what happens when the number of neutrons are more. Let's say we discussed about isotopes earlier. What were isotopes? Isotopes were, let's say, like, isotopes are like same elements that have different mass number. Means, let's say we have discussed the example of carbon 12 and carbon 14. In carbon 12 we had like proton 6, neutron 6. Carbon 14, proton 6, neutron 8. This is a very small element. Small elements are generally more stable as compared to larger element, bigger element. So here we see that number of neutrons can vary, number of neutron is more. If number of neutron is still more, there will be instability within the atom also. So in that case what will happen? Let's consider number of neutron यहाँ पे क्या है? 2 ज़्यादा है, 2 neutrons are more. So the thing is, there can be case when number of neutrons are still more. So to come out, to be more stable, it will try to convert a neutron into a proton. नहीं, चार्ज जीरो है, बट लेकिन मतलब इट इज एडिंग अप टू द मास ओवरऑल. स्टेबिलिटी के लिए मतलब लाइक इनसाइड द न्यूक्लियस, इफ स्टेबिलिटी इज टू बी अचीव्ड, मतलब ओवरऑल, मतलब जैसे होता है क्या है, लेट्स कंसीडर वी हैव अ बैंड. व्हाट मतलब लाइक एक होता है ना कि बैंड रबर, लेट्स से लाइक वी हैव रबर जिसमें दूध बांधते हैं ऐसा. तो इफ वी हैव लेट्स से 10 पेन्स एंड देन एक रबर, 10 के जगह पे हमने 14 लेके आया, तो रबर क्या हुआ? स्ट्रेच होगा, तो जिसके वजह से इनस्टेबिलिटी आएगी. लेकिन वो स्ट्रेच जो है, इट्स मतलब हियर ओवर हियर, दैट स्ट्रेच डज नॉट हैपन दैट वे एज रबर हैपन्स. ठीक है, later on when we discuss, we are going to discuss little more also, many other concepts are also there. ठीक है, we will understand about further subatomic particles. These are considered to be, let's say, like initial particles inside an atom, but this is not an end. Further studies, further research has been done. People have found fermions, people have found leptons, people have found many other, let's say, elements inside the atom. ठीक है, so like that is, let's say, the standard model of physics. We'll discuss about it. Are you understanding this part? So over here, when the number of neutrons is also more than what is needed, in that case the neutron will get converted into a proton. Neutron will get converted into a proton. So in that case what happens? Beta minus decay will happen. हाँ, it's going to release an electron, and then it's also going to release, let's say like anti-neutrino. It's going to release two things. When we talk about beta minus decay, okay, when we talk about beta minus decay, what happens, whatever is the element, right, whatever is the element, right, this element will release an electron, this element will release an anti-neutron, okay, plus, not anti-neutron, this is anti-neutrino. This is going to release an anti-neutrino, then it is going to convert this, then it's going to convert into a proton. Let's say earlier it was neutron, it's going to get converted into proton. This is known as beta minus decay. Beta minus decay में क्या होता है? Electron emission happens. Second thing, anti-neutrino emission happens. Then let's say like that neutron gets converted into proton. Beta plus decay या positron emission में क्या होता है कि one positron gets emitted plus one neutrino also gets emitted. इस केस में बीटा माइनस में एंटी न्यूट्रिनो होता है, बीटा प्लस में न्यूट्रिनो कम्स. व्हाट? न्यूट्रिनो gets emitted. What is neutrino? Many of us might have heard about it. It is there in news also all over. India is developing a neutrino detector. Neutrinos come into 3 different flavors: electron neutrino, muon neutrino, tau neutrino, right? Neutrinos are, let's say like massless particle, बहुत कम mass होता है, and they massless particle, chargeless particle, it is very difficult to detect them, but they are present, and neutrinos can pass through matter also. For example, this is the board, neutrino can pass through the board as well. Okay, so detecting the neutrino in the bare atmosphere is very difficult because of interference by other elements. So basically in India we are developing a neutrino detector which is underground. What we are doing, we are detecting neutrino detector which is underground, okay, and then it's going to detect the presence of neutrino. Okay, this is the thing. So is it understood what is beta decay? Beta decay. Beta decay में what happens? Does the atomic number change? Question.
Yes.
Think about.
Yes,
Although see, whenever neutrons are converted into proton, atomic number will increase by 1. One neutrino gets converted into one neutron gets converted into a proton. Atomic number will increase by 1. Mass number will remain same. When a proton gets converted into a neutron, one atomic number will decrease, but mass number will remain same. बीटा डिके में मैंने वो इनिशियली ऐसा बोल दिया था जस्ट टू सी कि मतलब हाउ मच वी आर अप्लाइंग. I am writing about it. Beta minus decay. Beta minus decay. Okay. So in beta minus decay, what happens, as we discussed, this is an element X, right? This is an element X having atomic number Z, mass number A. What happens in beta minus decay? Beta minus decay में क्या होता है कि one electron will be emitted. Means here beta minus decay में neutron will get converted. Neutron will get converted into proton, right? Neutron will get converted into proton, plus there will be an electron emission, there will be an anti-neutrino emission. Okay, so this is the thing. In beta minus decay, after this beta minus decay happens, yes, so X will be Z plus 1 and A will be same. Atomic,
Where does that electron come from within the nucleus?
Within the nucleus.
Okay. And why does a proton convert into neutron? Because the mass number would remain the same.
The
mass of proton and neutron is the same. So why is it? So
why does the neutron get converted into proton? to achieve stability, basically it happens in radioactive elements. Radioactive element में होता क्या है? Let me tell you how it happens. Okay, to understand this process, basically consider there is a big element. This big element is there. It has gone through a alpha decay. Alpha decay होने के बाद what has happened? Atomic number reduced by 2, mass number reduced by 2. Still it is not stable. To achieve stability, it is still not stable. Either the number of neutrons are more, number of protons are more. If number of neutrons are more, then it will go through beta minus decay to achieve stability. If number of protons are more, then it will go for beta plus decay. It is like that. This way it happens.
The main goal is to achieve parity.
Stability.
Proton and neutron.
It is not to equalize the number of neutron and proton. Because when we talk about uranium-235, uranium has an atomic number of 92 only. Mass number is 235. 92 into 2 करेंगे, 90 into 2 कितना होता है? 184 होना चाहिए. But number of neutrons are more than that. Are you understanding? Much more than that. So they are still stable to have more neutrons. But beyond a level, एक होता है ना, beyond a level, it's not, they are not able to, let's say, like withstand that thing. So 194 नहीं, 184 नहीं. अगर हम डबल करते हैं, लाइक वी आर कंसिडरिंग अ हाइपोथेटिकल सिचुएशन कि मतलब नंबर ऑफ प्रोटॉन 92 है, तो अगर नंबर ऑफ न्यूट्रॉन भी उतने होते तो मतलब लाइक एटॉमिक मास वुड हैव बीन 184, बट एक्चुअली इट इज 235, राइट? बिकॉज नंबर ऑफ न्यूट्रॉन्स आर मोर, बट और ज़्यादा होंगे तो डिफिकल्ट होता है. ठीक है, मतलब फॉर एग्जाम्पल यूरेनियम डज हैव अ आइसोटोप ऑल्सो विच इज 238. It has an isotope 238. It does have another isotope which is, let's say, like uranium, what, 235, 233 भी है. But generally जो reactions होते हैं, it happens through 235. ठीक है. And then plutonium is made out of uranium. Uranium से plutonium बनता है. And plutonium में number of protons क्या? Number of proton is equal to atomic number.
Mass number is equal to mean proton plus neutron हो गया.
Yes.
और नीचे हमारा atomic number 92 atomic number हो गया और उसका डबल कर रहा हूँ तो 184
हाँ
हो रहा है.
हाँ हाँ.
तो आप ये कैसे, मतलब 184 हो गया और 235 वैसे कह रहे हैं हम कि ज़्यादा है, तो आप ये कैसे कह रहे हैं कि न्यूट्रॉन ही ज़्यादा है, प्रोटॉन ज़्यादा है?
See, प्रोटॉन ज़्यादा होने से उसके चार्ज से पता लगेगा. When we talk about every proton has a charge plus 1.6 into 10 raised to power minus 19. ठीक है. ओवरऑल जो चार्ज है, मतलब द पॉजिटिव चार्ज दैट इट हैज़, ठीक है, जितने पॉजिटिव चार्ज है उतने इलेक्ट्रॉन्स को वो होल्ड करके रखता है आउटसाइड इट, न्यूट्रल रहेगा. ठीक है. आर यू अंडरस्टैंडिंग कि दिस इज एन एटम, दिस इज द न्यूक्लियस, इनसाइड द न्यूक्लियस प्रोटॉन्स आर देयर, न्यूट्रॉन्स आर देयर, आउटसाइड द न्यूक्लियस वी हैव इलेक्ट्रॉन्स. ठीक है. तो क्या है, द एटम इन इटसेल्फ इज न्यूट्रल. Generally atom in itself is neutral. Why it is neutral? Because जितने भी positive charge है उतना ही negative charge है, उतना ही electron है. That's why it is neutral.
तो electron is equal to proton.
In general it should be, लेकिन फिर भी क्या होता है? There is another case also कि number of electron that is there in outer shell, outermost shell, it is not equivalent to what it is required to bring stability. In that case, we see, let's say, like, you know, it is forming ions. It forms ions. Why ion? To bring stability बाहर से. लेकिन अंदर के बारे में अगर हम बात करें, when we talk about from inside, inside भी तो stability चाहिए ना. Inside मतलब like, you know, there is a building. In that building, the building is stable, but like, you know, there can be a house which is not stable inside the building. Maybe possible. Okay. So it is like that. So inside the nucleus also it is needed कि it should be stable. Okay. And those that are not stable, they are considered to be radioactive elements. And using those elements, we are, let's say, like doing nuclear fission reactions. And matlab like other kind of reactions are also happening, but generally nuclear fission reaction happens because of it.
Generally सर जो बाहर वाले इलेक्ट्रॉन है वो मतलब पॉजिटिव होंगे तो अंदर वाले जो प्रोटॉन है वो नेगेटिव है तो वो बैलेंस बना रहे हैं.
फ्री स्टेट में कोई भी एलिमेंट है वो न्यूट्रल
वो न्यूट्रल रहेगा, फ्री स्टेट में कोई है तो न्यूट्रल रहेगा, अदरवाइज इट विल स्टे इन फॉर्म ऑफ कंपाउंड्स, मतलब कंपाउंड्स मतलब लाइक मोर देन लेट्स से, हाँ फॉर एग्जांपल अगर हम बात करें H2O की, सो व्हाट हैपेंस इन H2O, basically hydrogen has a positive charge, another hydrogen has a positive charge, but oxygen has two negative charges. Okay, so that's why it attaches with 1 it is like that to bring valency on it, that's why it forms this thing. What is the atomic number of oxygen? 8. पहले वाले शेल में 2 होंगे, आउटर शेल में 6 होंगे, 2 बाहर से चाहिए, 2 बाहर से 2 हाइड्रोजन देता है, इट्स लाइक दैट. Is it understood this part? So this is the thing. So this is known as beta minus decay. Beta minus decay में क्या हो रहा है? Atomic number is increasing by 1. When we talk about beta plus decay is given another name, positron decay. Okay? What? It is known as positron decay. Let me write here. This was beta minus decay. Here I'm going to write down about positron emission. What? Positron emission. So let us discuss what do we mean by positron emission. It is just, let's say, concept which is just opposite to this one. There is an element X having atomic number Z, mass number A. When positron emission happens, one proton gets converted into a neutron, plus it releases a positron plus a neutrino, like that. Okay, positron are those particles that are similar to electrons, but they have a charge of 1.6 into 10 raised to the minus 19 coulomb. Positive charge, plus charge. So here what happens after positron emission? What's going to happen after positron emission happens? So the thing is, this atom, okay, I should have written this as Y. Why? Because atom itself changed, na? This is the thing. So it's going to change into Y, and then the atomic number will reduce by 1, mass number will remain same. This is known as beta plus decay or positron emission.
So what is the difference between neutrino and anti-neutrino?
Spin different होता है उसमें. Spin मतलब spin number होते हैं, they have a different spin altogether. Spin मतलब किस डायरेक्शन में वो रोटेट कर रहा है. हाँ हाँ, it's like that. बहुत सारी चीज़ें. हाँ मतलब that we are going to discuss about it. Spin number. Okay. Is it understood beta decay? Now we are going to discuss about another concept, and this concept is known as what? Gamma decay. What do we mean by gamma decay basically? Now here what happens? Initially when we talked about alpha decay, an alpha particle came out of it. 2 atomic number got reduced and mass number 4, means like helium came out of it. In beta decay, I mean like in alpha decay atomic number changed, mass number changed. In beta decay atomic number changed, mass number remained same. In gamma decay what happens? Neither atomic number changes nor mass number changes. What happens? Let's consider we conducted a nuclear reaction. After conducting a nuclear reaction, what happens? I mean like the atom, the element that was formed, it is not stable. Why? Because it may be at a higher energy level. So it will just release some form of energy in the form of gamma particle. So over here, let's say this is the atomic number Z, mass number A, right? After a gamma decay happens, gamma is represented by a symbol which is similar to Y. ऐसे करके होता है gamma. ठीक है, this is known as what? Gamma. It is just a symbol. Okay. जैसे अल्फा का ये सिंबल था, बीटा का ये सिंबल है, ऐसे गामा का ये सिंबल है. It's like that. This is just a symbol. So after gamma decay, what happens? the element remains same, right? But some form of energy is released. What? Some form of energy is released. Matlab some energy is emitted. This is gamma decay. In gamma decay, atomic number does not change. This is done just to bring stability. Higher energy state से थोड़ा lower energy state में आ जाता है. हाँ, excited state से stable state में आ जाता है. It's like that. Okay, this is known as gamma decay. Is it understood? Alpha decay, beta decay, gamma decay. So with this, now let us understand about another concept. Okay, the concept is, let's say we have been discussing that in nuclear fission reaction, reactions happened, and then what has happened means like, huge amount of energy was produced. And why energy is produced? How do we get to know? Means like, how do we get to know ki how means like radioactive reactions can happen, nuclear fission reactions can happen. Basically what happens inside the nucleus, right? Things are held together. Inside the nucleus, the things are held together by strong nuclear forces. What? Strong nuclear forces. That's why the nucleus remains stable. In case of radioactive elements, they have weak nuclear forces. That's why, let's say like, the atom is converted into other atoms. So when we talk about forces of nature, in the nature we do have different types of forces. What are the forces? We have the gravitational force, we have electromagnetic force, we have, let's say like, the strong nuclear force and weak nuclear forces. So let us discuss about this concept. What? Forces of nature. Forces of nature. When we talk about forces of nature, we are going to compare various forces of nature. One of the force of nature is known as strong nuclear force. What? We have a strong nuclear force. What is a strong nuclear force? It is the force within the nucleus that binds all the protons and neutrons together. That is known as a strong nuclear force. Apart from this, we do have another force which is known as electromagnetic force. What? Electromagnetic force, right? Or this is known as electromagnetic force. Third one is known as weak nuclear force. And then we have gravitational force. These are the four forces of nature. These are the four forces of nature. Now here we need to understand what is a strong nuclear force. Strong nuclear force is the force that acts inside the nucleus, that holds all the nucleons inside the nucleus together. This is a force that is there. And then when we talk about electromagnetic force or electrostatic force, these are the kind of forces, you can also say to be electrostatic force. These are the forces that are acting between charged particles. Positive charge particle attracts negative charge particle. Negative charge particle attracts positive charge particle. Two positive charge particles will be repelling one another. Two negative charge particles will be attracting one another. So you can say electromagnetic or electrostatic force like that. Okay. Next is weak nuclear force. What is weak nuclear force? Basically in radioactive elements, the force that is there inside the nucleus, it is less as compared to strong nuclear force as compared to those elements that are stable. So this force is known as weak nuclear force. Gravitational force, as we all know, Newton has said that like every body in the universe, okay, force is equal to G m1 into m2 upon r square. What is G? Gravitational constant, mass of first body. mass of second body, and r distance between the two bodies. Okay, so every body in the universe attracts every other body with some force, and this force is given by this, and g is gravitational constant. And here if we talk about, let's say, force that we experience on the earth, here in case of earth, this g value is replaced by small g value, and this small g is equal to 9.8 meter per second square. This is acceleration due to gravity. So now tell me which force is the strongest force in the nature? Strongest force in the nature.
So the capital G is constant for the universe.
हाँ, it is constant for the universe. I am saying कि मतलब here if we have to apply similar thing on earth, generally on earth our mass is considered to be negligible, right? So that way we calculate it. Okay, so tell me which force is the strongest force in nature?
Nuclear force.
Yes, he is saying nuclear force, he is saying gravitational force. बाकी लोग? Yes, madam. Lifeline. Yes, online people. This is not visible also, like he has done, I mean like the comment section is not visible. Okay. Maybe people might be commenting also, but it is not visible to me at this point of time if you are commenting something because of the setting that is done on the screen, right? So now we need to understand which force is the strongest and which force is the weakest force in nature. Okay. So the thing is, the gravitational force is the weakest force in the nature. The strongest force is the strong nuclear force. Then we have electromagnetic force or electrostatic force, the forces that are between the charges. Okay. Then we have weak nuclear force. The weakest force is gravitational force.
सर ये कह सकते हैं कि जो पीरियोडिक टेबल में सबसे ऊपर वाले जो एलिमेंट्स हैं उनमें इसको न्यूक्लियर फोर्स बहुत ज़्यादा है जो ऊपर वाले
हाँ, ऐसा भी नहीं बोल सकते because nuclear force also is proportional to the, let's say, like, you know, like there is a function, means like up to certain level, right, up to certain level it will depend on the number of nucleons, but beyond certain level, let's say, like, you know, the function goes down. It's like that. It is not linear. Are you understanding? Linear का मतलब है कि ऐसे कि मतलब अगर आप what you are saying कि जिसमें कम एटॉमिक नंबर है उसमें ज़्यादा फोर्स है, जिसमें ज़्यादा एटॉमिक नंबर है उसमें कम है. You are saying this way. It means like it is linear, but this function is not linear. This function is kind of, let's say, non-linear function. Initially वो बढ़ता है, बाद में कम होता है. It is that way. ठीक है, मतलब like this is in the nature. We cannot alter whatever there is in the nature. What we do, we try to analyze, we try to understand what is there. Okay, this is the thing. So strong nuclear force is the strongest force in the nature. This is the thing. And the thing is, like, we have also understood about this thing, E equals to mc square. Can anyone tell me what does it mean? Yes.
It says that when matter moves at the speed of light, it converts into energy.
ऐसा?
Actually, it is a mass energy relation.
Mass energy equivalence. It means mass can be converted into energy. It means a small amount of mass can be converted into huge amount of energy, like that. Energy can also be converted into mass. And in fact, when we discuss about God particle later, which is known as Higgs boson, Higgs boson are those particles that give mass to other particles. Basically, I mean like how the mass originated. Mass is not there कि मतलब एक जगह से दूसरे जगह आ गया. So the thing is like Higgs boson is the particle that gives mass to other particles. Because of his Higgs boson, particles are being formed in the universe. God particle. It is known as God particle, and the thing is like a person who has discovered this thing, he has initially given theory about it. But later on people have done experimental work on it, and the person who has done experimental work, who has proved that Higgs boson actually exists, Peter Higgs or some boson, this is name of two scientists. So someone who said that it actually exists, who has, let's say, done this particular thing, he was given Nobel Prize. They received Nobel Prize also related to it. When we talk about Nobel Prize, right, what are Nobel Prize basically? So there is a story.
After Alfred Nobel, and it is given by Norway and Sweden universities. नहीं दोनों actually कुछ portion
So let us have a quick discussion related to that. So when we talk about Nobel Prize, okay. So Nobel Prize is given, let's say, in commemoration of Alfred Nobel. Alfred Nobel. Who was Alfred Nobel? Basically, he was the inventor of dynamite. He has invented dynamite. And so dynamite is used for explosion. For example, if you have to construct road in mountains, what you do? You do explosion so that, like, you can make roads there. So Alfred Nobel has invented this particular thing, and let's say, like, in that country where he belonged, I think Sweden, right? So huge construction activities happened, and his dynamites were being sold, right, in huge number. He became one of the richest person in Sweden long back. But the thing is, what has happened? There was a time where his younger brother, I mean, like, he had two brothers, I think. So his younger brother went to France, and let's say, like, he died in France. And after his younger brother died in France, basically one newspaper, very prominent newspaper of that time, published that the Maut ke Saudagar means the, I mean, there is an English conversion. It's like, huh? नहीं no, there is sentence. Basically it means मौत के सौदागर. हाँ हाँ ठीक है. The dealer of death ऐसा कुछ था, ठीक है, मतलब like, the merchant of death. So they have said the merchant of death. Okay, what he said, कि his younger brother passed away. His younger brother also had a surname Nobel, Alfred Nobel. He is some Nobel, right? So in that country, in France, the newspaper people, they felt that Alfred Nobel passed away, and in the newspaper article they have published that the merchant of death passed away. What? Passed away. After reading this newspaper article, basically Alfred Nobel got disheartened. He felt that, like, I am an inventor, I am a scientist, I have developed this particular thing, and I have developed it for some good causes for the humanity. So he felt that, like, I don't want to leave my legacy this way. And he was one of the richest person. So that's why he has written a will. Will means related to the property that he has. He has said that out of all the money that I have, right, so this money should be used for honoring all those scientists who work in the field of physics, chemistry, biology, etc. Means he left huge amount of money with the will, and that's why Nobel Foundation was built. And the work of the Nobel Foundation is to manage the money of Alfred Nobel that he had. How do they manage money? They invest it here, there and all, so that that money also keeps on growing. And out of that money, let's say, like, whenever Nobel Prizes are given to people, so people are also given cash prizes associated with it. So this is the thing. So this Nobel Prize has been established after Alfred Nobel, okay, after his will. It is from a single individual person. And later on, let's say, like, that Nobel Foundation has given this responsibility to the King of Sweden. Basically, I think it's still Sweden is a monarchy. Okay, means like kings rule over there. So like now it has come under the ambit of that kingdom itself. So king.
Norway is monarch.
Okay.
Sweden, but they are both democratic.
Democratic and monarch, like that. I mean, yes, yes. Haan, haan. Maybe, I mean like we don't know much about their polity. So basically they have this structure, and now it is under the royal patronage. I mean like royal people, they manage this particular, they make it sure that Nobel Prizes are given. In fact, last year Nobel Prize in physics was given to attosecond physics. Attosecond physics. We will discuss about what do we mean by attosecond physics. So this is related to Alfred Nobel. Okay. Apart from this, having discussed this particular thing, now let us discuss about another important thing. We have seen forces of nature. Now we are going to see another part associated with it. I mean like this is going to be a separate discussion. Let us understand about what? Signals. What? Signals. What do we mean by signals? This is going to be very important because UPSC has asked many questions in the past that are related with this topic. The core idea is this, and other things are derived from it. I mean like it is like that. Signals. What are signals? Anyone who can tell me? It becomes very difficult to define the basic things. This is, I mean like it's not only for me, it's for all of us.
Anything which gives us indication.
Anything which gives an indication. Fair enough. So basically we are going to discuss about what are signals, what are different types of signals. We will discuss about characteristics of signals also. So basically when we talk about signal is a continuous function. It is a continuous function of some changing thing. For example, let's say, let me draw a signal for you. This is a representation of a signal, and signal has various characteristics. What are the characteristics that a signal has? It has various characteristics associated with it. Number one, let's say, amplitude. What do we mean by amplitude? A is represented by this. Height. For example, when we hear sound, the loudness of the sound, the volume, loudness of the sound is represented by amplitude. Okay. So this is amplitude. Apart from this, it does have another thing which is known as wavelength. What? Wavelength. Amplitude is represented by the symbol A. Wavelength is represented by the symbol lambda. How do we calculate wavelength? Huh? Distance between two points in a periodic signal that are in same phase. Technical, little bit technical, okay? It's like that. So, distance between this particular point and this point will be called as wavelength of the signal. Wavelength of the signal. Apart from this, it has another characteristic which is known as what? Frequency. It is represented by this symbol F, or sometimes it is also represented by nu. It is known as NEW. Nu. जैसे अल्फा बीटा गामा देखा था, ये वैसा है, ये V नहीं है, थोड़ा सा अलग है, tilted. ठीक है? So this is frequency. What is frequency? Frequency simply means, let's consider I have made a frame to observe this signal. So through this frame, any number of cycle of this signal that passes per second is called as frequency. एक सेकंड में कितने repeated cycle pass हो रहा है, that is known as frequency. Okay, frequency is number of cycles per unit time, per second. When we talk about AC signal, alternating current that we have in our home, AC signals can be represented using this. Okay, and AC signals has a frequency in India. It has a frequency of 50 hertz. So frequency has a unit of hertz. ठीक है, it is Hz लिखते हैं, this is like that. Apart from this, it does have another characteristic also. What is that characteristic? It is known as phase of the signal. Phase of the signal. Phase क्या होता है? Phase is the angle. जैसे सिग्नल जब अराइज होता है इनिशियल, जो भी phase is represented by theta और phi, इसको we read it as theta, इसको रिप्रेजेंट we read it as fi, ऐसे लिख देते हैं, ठीक है. phi मतलब just to make you clear कि how do we pronounce it. Phase. Phase is this angle. Phase is angle. Phase does not have any unit. Like degree में हम calculate करते हैं 20 degree, 30 degree like that. So this is the thing. So these are characteristics associated with the signal. Now here we need to understand that all the let's say like we see light waves. What is the speed of light? 3 into 10 raised to power 8 meter per second. This is the speed of light in vacuum. Speed of light in vacuum or speed of light in space is 3 into, like speed of light in space is equal to 3 into 10 raised to power 8 meter per second. This is approximately, okay, approximate figure. This is the speed of light in vacuum. Does light travel with the same speed everywhere? No. The speed of light varies when it, let's say like when it passes through certain medium. For example, speed of light will vary in water. Speed of light will vary when it passes through what? Glass, right? Through glass prism. So that's the thing. So this is, let's say, characteristics of signal. These are, let's say, some of the important characteristics associated with signal. Apart from this, what we are going to do, now we are going to discuss about various types of signals. One, signals or waves, number one. Let's discuss about longitudinal waves. What? And before this we have matter waves. What? Matter waves. What are matter waves? Waves that pass through matter. For example, through air or through water, right? Or through any kind of matter, that is known as matter wave. So here longitudinal waves are an example of matter wave. What happens in longitudinal waves basically? What happens in longitudinal waves? So let's say I have a source of sound. Okay, from here sound is generated. Okay, source of sound. So how it is going to travel on air? It's going to push the medium in the air. Push, then come back, push, come back, like that it moves. So the thing is, in the direction in which the particles vibrate, in the same direction the energy also travels, the wave also travels. So the direction of propagation means the direction in which it travels, right, is same as the direction of vibration of the particles. In case of longitudinal waves it happens, okay. So direction of vibration, and this thing, whenever we have far space thing and near space thing, they are named differently. It is known as trough, crest,
compression और rarefaction.
हाँ compression and rarefaction. हाँ एक मिनट. So this is just a minute. This is known as, नहीं इसमें भी हम ऐसे लिखते हैं, crest trough ऐसा लिखते हैं, मतलब like if we share in that manner. Let me write down it as compression and this one is known as rarefaction. What is the speed of light in air? Speed of sound. in air. 314, 343, I think it is approximately 343 meter per second. This is the speed of sound. देख लेना. This is the speed of sound in air. Speed of sound varies in different mediums. For example, when the sound will travel through water, its speed will be different. When it travels through aluminium, it will be different. When it travels through, let's say, steel, it will be different. Doctors use a stethoscope, right? Why? To amplify the sound, right? Because like when they put it stethoscope nearby your heart, so the thing is he hears the voice in a louder, let's say, like, you know, louder way. It is, let's say, like, you know, its amplitude is increased. Basically he hears more. Why? Because now the sound was traveling through that particular pipe, stethoscope. वहाँ पे it is traveling through a different medium. ठीक है? So that's why it is heard louder as compared to normal thing. It is not fiber. नहीं नहीं, स्टेथोस्कोप में आई थिंक दे यूज एल्यूमिनियम टाइप ऑफ थिंग. मतलब ऊपर से वो दिखता है रबड़ जैसा, लेकिन उसके अंदर वो मेटल होता है. मतलब लाइक व्हेन साउंड ट्रेवल्स थ्रू मेटल, इट मतलब प्रोड्यूसेस मोर. इट्स लाइक दैट, इट एम्पलीफाइज इट. ठीक है, एम्पलीफाई होता है. इट्स लाइक दैट. तो मतलब आई टोल्ड ना कि साउंड ट्रेवल्स एट डिफरेंट स्पीड्स इन डिफरेंट मीडियम. दैट्स द थिंग. ओके, सो दिस इज वन ऑफ द थिंग. अपार्ट फ्रॉम दिस, जैसे फॉर एग्जाम्पल वन थिंग इज वी डिस्कस्ड अबाउट stethoscope, right? Second is when we talk about moon, on the surface of the moon we don't have atmosphere. We don't have atmosphere on the moon. Means like here we have air, there we do not have air. So on moon, if two astronauts are standing nearby one another, if they speak to one another, the other person will not be able to hear. Why? Because there is no medium through which the sound can travel. Sound needs a medium to travel. Okay.
So all longitudinal waves do need a medium.
Yes, all of them need a medium. So longitudinal waves, what? They need a medium to propagate. They need a medium to propagate. This is an important thing for us to understand. Otherwise, it will not be able to travel. It will not be able to propagate. This is the thing. Okay. They need a medium to propagate. This we have discussed. Compression, rarefaction. So the direction of vibration of the particles is same as the direction of propagation of the let's say sound wave. Okay. Is it understood? Longitudinal wave. Now we are going to discuss about transverse wave. Transverse wave. Now when we discuss about transverse wave, what are transverse wave basically?
Particles move perpendicular to the direction of propagation of the light.
Yes, particle moves perpendicular to the direction of propagation of particles in the medium. Transverse wave, how can we represent transverse wave using signals? We can represent them using this signal. Okay. So the thing is, example of any transverse wave. Yes, example. Light. नहीं. Radio wave नहीं.
Light is not transverse.
It is electromagnetic wave. We'll discuss about it. Yes. आप बताइए. अच्छा, वो अर्थक्वेक वेव वाला. अच्छा. लव वेव भी तो होता है. There is love wave. Actually, like what it does, it vibrates in a vibrates ऊपर नीचे करता है. मतलब it's like that. So basically, the example will be water wave. Water wave matlab when I have a pond, okay, let's consider I have a pond like this. In the pond I have, let's say, water, and what I do, I throw stone in the pond from here standing. ठीक है, stone throw किया यहाँ से. Okay, what has happened? After then, like we will see a kind of, let's say, water wave moving in this fashion. Wherever we have thrown, वहाँ से initiate होता है wave and it moves like this. So the particles in river, it goes up and down this way. It goes up and down like this. Means like, particles are going up, down. But actually the movement of this thing, movement of the wave is happening outside, outward. That is known as transverse wave. So like throwing, example would be throwing a stone in river. Throwing a stone in river is an example of transverse wave. Now we are going to discuss about another wave, okay. Another wave, it is known as what? At the end, we are going to solve some previous year questions based on the concept that we are discussing now. Lot of questions are there, okay. So this is the thing. So electro, and also we will give you printed notes, okay, printed materials of whatever we discuss in the classroom. Okay, so printed notes will be given on the next day. Today we are conducting the class. Whatever I discussed today, tomorrow I will give you the printed note, so that like you can revise it from the notes itself. So it is electromagnetic waves. What happens in case of electromagnetic waves? Okay. Let me use a color. I hope this is visible. Okay. Let me draw an electromagnetic wave. Later on I am going to explain this to you. You can also draw along with me.
So
3D. Yes. लग नहीं रहा है? So here, let's say like we will be having three different axes. Axis means, let's consider I have a line like this. So this is x-axis, I have drawn in this manner. I can have a vertical line also. Let's say this is y-axis, right? X-axis, y-axis, this is in this plane. This plane means like this board, one line is drawn in this direction, one line is vertical direction. Then we can have another axis, which is, let's say, directly going this way. I mean like perpendicular to this one. That is z-axis. Okay, this is x-axis, this is y axis, and that is z axis. So similarly here we have 3 axes. Over here what is happening, when we talk about, let's say like if I have to demarcate these axes differently, one plane, I mean like since we do have 3 axes, now here try to understand, let's say I have only 2 axes, x axis and y axis. Between x and y axis I have a plane like that. Similarly, if I have, let's say like y axis and z axis consider it to be perpendicular to this. So between y and z I can have another plane, and similarly between x and z I can have another plane like that. So let's consider this is, here we have electric waves, magnetic waves and magnetic waves. Magnetic waves is represented by yellow lines. Electric waves is represented by this one. So electric waves and magnetic waves, let's say like they are electric waves, let's consider it is in z axis, okay, z, and it is in x, what, z and x. Electric waves, consider they are traveling in z and x plane, zx plane. Similarly, magnetic waves, consider they are traveling in y and x plane. Which plane? Y plane and x plane, like that. So the thing is, finally, like in which direction it will be moving? It will be moving to the perpendicular to the direction of propagation. Wherever the wave travel, let's say like waves are moving in this direction, means like one thing is in this direction, second is in this direction, like that. But it is moving in this direction. This is known as electromagnetic wave.
तो इनका मूवमेंट सर उस तरफ है?
हाँ, मूवमेंट उस तरफ है. एक तो प्रोपेगेट ऐसे ऐसे कर रहा है, एक ऐसे ऐसे कर रहा है, वो इधर जा रहा है. वेव का प्रोपेगेशन, डायरेक्शन ऑफ प्रोपेगेशन, डायरेक्शन ऑफ propagation of the wave. This is the direction of propagation. Propagation means travel. In which direction the wave is traveling? In this direction. Okay, wave is traveling in this direction. Now we need to understand some important properties of electromagnetic waves. Number 1, electromagnetic waves travel at a speed of light. What it does? They travel at the speed of light in vacuum. Okay, so what will be the speed of electromagnetic wave? 3 into 10 raised to power 8 meter per second approximately. This is approximate figure. So here we need to understand the mobile phones that we are using. What is the speed of sound in air? 314 meter per second. How much? 343 meter per second. This is the speed of sound in air. But like we are able to make call and speak to someone in Dubai, in United States of America instantly. Why? Because like inside the mobile phones, we do have some devices that is able to convert one form of energy into another form. What? It is able to convert one form of energy into another form. It is able to convert the, let's say, sound waves into electromagnetic waves. So generally the waves, signals that are transferred, it is transferred in the form of electromagnetic waves. That's why we are able to communicate at a very fast rate. I mean like I am saying from here, they are responding from there, far away, and it is happening in real time. It is because, let's say like we are converting the form of energy from sound wave into electromagnetic wave, and then let's say this is known as modulator. What? Generally modulator, voice modulation. Okay. then voice modulation, amplitude modulation, frequency modulation. We do have different types of modulation. ठीक है, modulation करने के बाद we actually change the form of it and then we let's say send somewhere else, then we receive it. तो एक तो मॉड्यूलेटर होता है जो कन्वर्ट करता है साउंड वेव को इलेक्ट्रोमैग्नेटिक में, एक डीमॉड्यूलेटर होता है जो इलेक्ट्रोमैग्नेटिक को साउंड में कन्वर्ट करता है. सो दैट्स व्हाई द कम्युनिकेशन इज हैपनिंग इन रियल टाइम. कैन एनीवन टेल मी हु वाज द फर्स्ट पर्सन हु हैज इन्वेंटेड टेलीफोन? Yes, Alexander Graham Bell. Okay, so basically like he said that like I have found out a technology that will enable me to speak to someone far away. Okay, and because of this his roommate felt that he became mad. At that point of time nothing was there. I mean like someone suddenly says कि मैं यहाँ पे बैठ के उधर मतलब इंडिया में बात मतलब यूएसए में बात करूँगा, बोले पागल हो गया. Actually he got him sent to psychiatric place. I mean like he stayed there for a long period of time. But later on he has proved that this is, let's say this is possible, this will be able to do. And later on people have, let's say like send wires, transcontinental wires from the ocean, within the ocean. Okay, it is like that. So anyone who is inventing, anyone who is discovering, so these are the people who will come up with those ideas that do not exist. Do not exist means like you may not have thought about it, but maybe at this point of time those people may seem to be mad to you, but the thing is like they have visualized something that like we were not able to think in that line. Later on it proves to be like they have been right in many cases. When we talk about Albert Einstein has given theory of relativity, special theory of relativity, general theory of relativity. So basically Albert Einstein has said that mass can be converted into energy, right? Energy can be converted into mass. People believed he has gone mad, but later on what has happened? Atom bomb was created. It was tested in Hiroshima and Nagasaki. People got to know that actually, let's say like small amount of mass can be converted into huge amount of energy, like that. Long back he has predicted, in 1915 he has predicted that gravitational waves exist. What? Gravitational waves exist, and it was discovered in 2015, 100 years back. 100 years before he has predicted that it exists, 100 years back people have developed instruments to identify whether they actually exist or not. Later on, after 100 years it was found that it actually exists. Okay, apart from this, so is it understood this part?
Yes, sir.
Electromagnetic wave, we are going to see images also of electromagnetic wave. We are going to solve some questions as well. Okay, so the thing is, the light that we can see, light, white light, it's also a form of electromagnetic wave. It's also a form of electromagnetic wave. Electromagnetic waves exist in various forms that are not visible to human eye. Only the visible part of the spectrum is visible to us. When we talk about electromagnetic spectrum, okay, so we are going to discuss this part. Later on I am going to go back to that discussion that we had. Okay, what? Electromagnetic spectrum. What is electromagnetic spectrum?
Radio waves are EM waves. Radio waves are EM waves.
Yes, radio waves are electromagnetic waves.
आपने उसको डेवलप बोल दिया वैसे.
इलेक्ट्रोमैग्नेटिक बोला था आपने या ट्रांसवर्स वेव बोला था? हाँ,
मैंने रेडियो वेव्स बोला था.
वो तो ट्रांसवर्स का डिस्कशन कर रहे थे ना उस टाइम पे, हम ट्रांसवर्स का डिस्कशन कर रहे थे हम. Now we came into this part, is electromagnetic spectrum. What is spectrum? Spectrum basically, जैसे अगर हम रेनबो के बारे में बात करें, रेनबो, it is a spectrum of different colored lights. Spectrum मतलब जहाँ पे more than one color of light can be visible. It is like that. Similarly, when we talk about electromagnetic spectrum, it is composition of all different forms of waves that are there. different forms of wave. That includes let's say like X-rays, ultraviolet rays, visible light, radio waves, right, infrared waves, all these kind of जितने भी wave है उनको together we say electromagnetic waves. And जो electromagnetic waves होते हैं, ठीक है, only a minuscule portion of it is visible to us, which lies in the visible range. जैसे sound के केस में क्या है, we are not able to hear all sounds. Human beings have capacity of hearing sound in a certain range, 20 decibel से लेके 2000 decibel के बीच में लगभग. It is like that. We are not able to hear all different forms of sound that actually exist. When we talk about dogs, they are able to hear more, right? Different, let's say, animals are there, they are able to hear, they have a hearing capacity of more. That's why when we are sitting over here, dogs are able to predict that someone is coming, like that. So because they have more range of hearing, right, they are able to hear. Similarly, what happens, human beings have limited capacity of seeing, right, electromagnetic waves. We can see only some portion of the electromagnetic waves, not all the portion. So the portion that we can see, it is known as visible spectrum. And inside the visible spectrum, we have ultraviolet we have this thing, rainbow, that जिसको हम बोलते हैं. You might have done this thing in school. क्या? विबग्योर. विबग्योर हम कैसे पता लगता था? We used to do prism वाला experiment. We had a prism. So what we used to do, in this prism we used to pass white light. White light को पास करते थे, इसके अंदर से वो लाइट जो है अलग अलग कलर का हो जाता था. मतलब अभी तो मतलब like 7 colors. I am just drawing, let's say like with जो भी कलर यहाँ पे दिख रहा है, but don't take it that way कि यही कलर एग्जिस्ट करता है. You understand? तो it is like that. तो इस प्रोसेस को क्या बोलते हैं? हाँ, डिफ्रैक्शन नहीं, रिफ्रैक्शन नहीं. रिफ्रैक्शन हो रहा है, बट व्हाट इज दिस प्रोसेस नोन एज? Dispersion of light. This is known as dispersion of light. Dispersion of light means when white light separates into various constituent colors. ठीक है? That is known as dispersion of light. Why dispersion of light? Generally what happens, we discussed that the speed of light varies in different medium. The speed of light in vacuum is 3 into C is equal to 3 into 10 raised to power 8 meter per second. But when light travels through what? Any other medium, its speed will vary. So generally this white light is composed of various frequencies. Since it is passing through another medium, so these frequencies get divided. So that's why these frequencies, I mean like here, over here, if we have a screen, let's consider I have created a screen over here, right? So in this screen, I will be able to see all the different colors. What? I'll be able to see all these different colors. Means like I'm just drawing it for our sake, but like ऐसा थोड़ा सा real में is little different from it. Okay. So in this screen, all the different color bands is visible. Okay. Why? Because the speed of light is different in different medium. Okay. And the thing is, when we talk about electromagnetic spectrum, here one more thing, C is equal to nu into lambda.
Yes, yes.
Nu means frequency. Okay. So what we need to remember is that amplitude of a signal will be inversely proportional to the frequency of the signal. जितना ज़्यादा उसका वेवलेंथ होगा, वेवलेंथ, उतना ही कम फ्रीक्वेंसी होंगी. जितनी ज़्यादा फ्रीक्वेंसी होंगी उतना कम वेवलेंथ होगा. let us quickly do a comparison. Okay, we are going to do a quick comparison of these things. Let me draw a few signals for you, and like you need to tell me which signal has more frequency and which signal has more wavelength. Okay, so we are doing comparison of two things. Number one, lambda is wavelength. We discussed about it in the past. Lambda is wavelength and f is frequency of the wave. Okay. Yes, many people have written so many things. Now it is visible. Okay. So now we are quickly going to draw a few signals. Let's consider this is one of the signal. I am drawing another signal. We are not doing exact mathematical calculation, but like we are comparing two signals. Let's consider it has a wavelength of 1, it has a frequency of 1. It has a wavelength of 2, lambda 2, it has frequency 2. Now tell me, when we compare the wavelength, which wavelength will be high? So here, number 1, when we compare the wavelength, so lambda 2 will be greater than lambda 1. Second thing, when we compare frequency, so f1 is greater than f2. Frequency 1 is greater than frequency 2. Now, seeing this particular thing, now let us come to this point. Just a minute. No, I think same material have been. Okay. I have taken it. Yes. So this is an electromagnetic wave that we had drawn in the past. Okay. This is the thing. So this is electromagnetic spectrum. I wanted to show electromagnetic spectrum to you. Now over here what is happening is that all the frequencies, right, of signals that we receive, basically like for us the source of energy is sun. From sun all the kind of waves are coming to earth. Not only earth, sun is emitting energy in all directions. We are receiving a very small portion of energy on earth. So basically what happens, the energy that we are receiving from the sun, they are in the form of waves, electromagnetic waves. And so these waves, let's say like, range from radio waves to, let's say, gamma rays. So how do we categorize these waves? Based on what is their frequency and what is their wavelength, based on their wavelength and frequency. So basically when we talk about radio waves, right, their wavelength is of the order of 10 raised to power 3 meter. मीन्स बहुत बड़ा, मतलब 1000 मीटर्स के बराबर वेवलेंथ है, मतलब बहुत बड़ा वेवलेंथ. When we talk about microwave, the wavelength is low, 10 raised to power -2. Infrared wavelength is still low. Visible light, जो visible light जो हम देख रहे हैं, इसका वेवलेंथ बहुत कम है, 0.5 into 10 raised to power -6. ठीक है. Ultraviolet, its wavelength is very low. X-rays wavelength is still low. Gamma ray wavelength is very low. तो क्या है? Wavelength is going down when we are moving from radio waves to gamma rays. Okay. Then second part is, let us see their frequency. ठीक है. Wavelength को like how they have compared, उन्होंने मतलब like they have compared it this manner. Let us talk about frequency, how the frequency is changing. So when we talk about frequency, radio wave का wavelength इतना था, frequency इतना है. Frequency is measured in hertz. Frequency is more, मतलब लाइक यू नो फ्रीक्वेंसी जो है, फ्रीक्वेंसी ऑल्सो की यहाँ पे वेवलेंथ कम होते जा रहा है, फ्रीक्वेंसी इंक्रीज होती जा रही है, ठीक है। फ्रीक्वेंसी इन केस ऑफ माइक्रोवेव फ्रीक्वेंसी 10⁻8 हर्ट्ज, इंफ्रारेड 10⁻12 हर्ट्ज, ठीक है। विजिबल लाइट 10⁻15 हर्ट्ज, ठीक है। अल्ट्रावायलेट 10⁻16 हर्ट्ज, एक्स रेज 10⁻18 हर्ट्ज, गामा रेज 10⁻20 हर्ट्ज। हाँ, वी आर जस्ट कंपेयरिंग इट, कंपेयरिंग की वेवलेंथ घट रहा है, wavelength is high here, wavelength is going down as we are moving from radio waves to radio waves, microwaves, infrared, visible, ultraviolet, X-rays, gamma rays. But what is happening? The wave, the frequency, wavelength is decreasing, frequency is increasing. Means frequency and wavelength are inversely proportional to one another. This is the thing. From here, what we need to do is, like, UPSC has asked a question in the past, and in that question basically UPSC has asked frequency range of visible light. कौन सा? जो visible light है उसका frequency range उन्होंने पूछा है. So how do we get frequency range of visible light? For example, ये जो है ये visible spectrum है, यहाँ पे जो हम देख रहे हैं ना, it is enlarged, ये छोटा सा ये it is enlarged. So it is shown 400 to 700 के आसपास. This is an approximate figure. It is generally 375 से लेके 375 हर्ट्ज, ठीक है, से लेके वहाँ तक है frequency. Are you understanding? This is the frequency range. So based on this, I will share the document with you, ठीक है, मतलब tomorrow. Now we are understanding this part. This is a previous year question UPSC from this topic. We are going to solve many questions. Number 1, with reference to visible light communication. What? Visible light communication. मतलब communication is happening using visible light. जैसे like जब हम रेडियो सुनते हैं ना, रेडियो, तो उसमें रेडियो वेव्स होते हैं, इसलिए उसका नाम रेडियो दिया है. रेडियो में भी अलग अलग फ्रीक्वेंसी का यूज़ करते हैं. एक यूज़ करते थे AM, एम्पलीट्यूड मॉड्यूलेशन, शॉर्ट वेव, SWB. जब इफ़ एनी वन ऑफ यू हैव ऑपरेटेड रेडियो प्रीवियस, जो पहले होता था, उसमें ना चैनल्स हम बदल सकते थे पीछे स्विच करके, ऐसा ऐसा करके. उसमें SW लिखा रहता था, AM लिखा रहता था, FM लिखा रहता था. SW शॉर्ट वेव, AM एम्पलीट्यूड मॉड्यूलेशन, ठीक है, FM फ्रीक्वेंसी मॉड्यूलेशन, ठीक है. जो FM है मतलब उसके दिमाग में चल रहा था कि FM क्या होता है. हाँ हाँ, नाउ इट इज़ लाइक वी हियर FM, मतलब अभी तो बंद कर दिया, लेकिन पहले FM बहुत चलता था स्मार्टफोन आने से पहले, ठीक है. सो इट्स लाइक दैट. विद रेफरेंस टू विजिबल लाइट कम्युनिकेशन टेक्नोलॉजी, विच ऑफ द फॉलोइंग स्टेटमेंट्स आर करेक्ट? दे हैव गिवन 4 स्टेटमेंट्स. नाउ फर्स्ट, विजिबल लाइट, देखो विजिबल लाइट उन्होंने बोला है, सो विजिबल फ्रीक्वेंसी रेंज में आएगा. सो 375 टू 780 नैनोमीटर रेंज, ठीक है. दिस इज राइट. VLC is also known as long range optical wire communication. विजिबल लाइट के बारे में जो हम बात करें तो वो लॉन्ग रेंज के लिए नहीं होता, शॉर्ट रेंज के लिए होता है. हाँ, ठीक है. तो इट्स लाइक दैट. थर्ड, VLC can transmit large amount of data faster than Bluetooth. This is right. VLC has no electromagnetic interference, ठीक है. Although electromagnetic interference होता है, ठीक है, इलेक्ट्रोमैग्नेटिक इंटरफेरेंस होता है, बट द थिंग इज लाइक द डिवाइसेस दैट वी ऑपरेट इन सच अ मैनर सो दैट इंटरफेरेंस कैन बी मिनिमाइज, कैन बी रिड्यूस्ड, ठीक है, बहुत ज़्यादा. बट लाइक UPSC हैज़ गिवन ऑप्शन वेयर, मतलब लाइक उसमें ऐसा है ही नहीं 1 and 3 वाला. तो 1, 3 and 4, मतलब लाइक यू नो इंटरफेरेंस, डिफ्रैक्शन, दीज आर एसोसिएटेड विद सिग्नल्स, ठीक है. इंटरफेरेंस, डिफ्रैक्शन इज एसोसिएटेड विद सिग्नल्स. अगर हमारे पास 2 टाइप के सिग्नल है, वो जब इंटरफेरेंस करते हैं तो उसके वजह से क्या है, या तो मतलब लाइक उसकी इंटेंसिटी बढ़ जाएगी या इंटेंसिटी घट जाएगी, ठीक है. दैट इज नोन एज इंटरफेरेंस. ऐसे डिफ्रैक्शन होता है, दैट्स अ डिफरेंट थिंग. सो इज इट अंडरस्टूड? इज दिस क्वेश्चन? हाँ, नहीं, करेक्ट पूछा है, करेक्ट पूछा है. हाँ 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 हाँ, उस तरीके से होता है तो ओनली 2 ऑप्शंस आर करेक्ट. यस, मतलब जो नया पैटर्न है, That way only 2 should be the correct. But like this is like we will go by this 1, 3 and 4. Is it understood, this question? Now let us see another question also. This is another question, UPSC PYQ 2015. पहले पूछा था. The known forces of nature can be divided into 4 classes via gravity, electromagnetism, weak nuclear force and strong nuclear force. With reference to them, which of the following statement is not correct? ये ध्यान रखना. हम पढ़ते नहीं है पूरा स्टेटमेंट को. Not correct. It says gravity is the strongest of all the forces. लोगों को लगता है कि यही ठीक है. ठीक है, ठीक है. तो this मतलब option, this option is right, but like this is not correct. It's electromagnetism acts only on particles with electric charge. ये we discussed today. Weak nuclear force causes radioactivity. We discussed alpha like alpha क्या बोलते हैं? Alpha decay, beta decay, gamma decay. We discussed today. So we understand this part. We understand this part also. Strong nuclear force hold protons and neutrons inside the nucleus of an atom. M लिख देता हूँ मैं. ठीक है, मतलब copied तो वो है. ठीक है. Is it understood? Yes. Okay. Now let us move to another question. It says, with reference to near field communication technology, prelims में application, ठीक है, जो भी हमने सीखा उसको हम apply करेंगे, right? It says with reference to near field communication technology, which of the following is or are correct? They have given 3 statements. Number 1, it is a contactless communication technology that uses electromagnetic radio fields. Near field communication, near मतलब पास वाला, ठीक है, तो इलेक्ट्रोमैग्नेटिक रेडियो फील्ड्स, ठीक है, दिस इज राइट. देखो इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम में कोई भी सिग्नल है, चाहे वो एक्सरे है, चाहे अल्ट्रावायलेट है, कुछ भी है, उसको इलेक्ट्रोमैग्नेटिक नाम दे सकते हैं. इलेक्ट्रोमैग्नेटिक रेडियो, इलेक्ट्रोमैग्नेटिक विजिबल, बिकॉज दे आर इलेक्ट्रोमैग्नेटिक वेव्स, इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम. वी डिस्कस्ड अबाउट इलेक्ट्रोमैग्नेटिक सिग्नल्स. दिस स्टेटमेंट इज राइट. सेकेंड, near field communication is designed for use by devices which can be at distance of even more than a meter from each other. Near field communication, let me tell you क्या है. Near field communication का मतलब है आपके पास डेबिट कार्ड है. You have a debit card and then you are going to a showroom. Nowadays what people are doing, earlier we used to take debit card and credit card, we used to swipe. Nowadays we just place it near and then they are able to debit money from here. मतलब उसमें आपने सेट किया होगा कि ऑटो डेबिट इतना लिमिट का होगा या फिर उसके ऊपर मेरे पास OTP आना चाहिए, लाइक दैट. हाँ, जैसे मेट्रो कार्ड है. आर वी अंडरस्टैंडिंग? तो वो 1 मीटर दूर से वो कैच नहीं करेगा. अरे मतलब लाइक वी हैव टू ब्रिंग इट नियर even if we are not touching, ठीक है, we have to bring it near, so it does not work 1 meter. नहीं तो वो कोई भी पैसेंजर उधर आता ना तो सबका स्वाइप हो जाता. Are we understanding? It's that way. So second is not correct. Now third, near field communication use encryption when sending sensitive information. Encryption होता है. Encryption means converting the data into a different encrypted format. ठीक है, we will discuss about encryption also, decryption, different types of encryption, decryption. That's the thing. So ये first and third are correct. Correct answer is option C. Is it understood? बहुत difficult नहीं है. It is about application of the basic principles, application of basic knowledge that we observe every day. कुछ we are going to read from class. Some of them we already know. ठीक है, लेकिन we need to apply it. ठीक है, it's like that. Now let us talk about another question. It will be little difficult because as of now we have not discussed about these things, but let us see. Consider the following statements. Let's see, I mean like anyone who might have read, let's say like earlier, not in today's class because we did not cover these topics yet. पहले ऑप्शन के बारे में क्या है आपका ऑब्जर्वेशन? हाउ मेनी आर सेइंग करेक्ट, हाउ मेनी आर सेइंग इनकरेक्ट? इट सेज लाइट इज अफेक्टेड बाय ग्रेविटी. Can anyone give me an example? Huh? Black hole. Yes. Anyone else? Black holes is a good example. ठीक है. लेकिन gravitational lensing is more closer example. What gravitational lensing? मतलब when light is passing near the massive bodies, so it appears that they are brighter as compared to their actual thing. ठीक है. That is known as gravitational lensing. तो light is affected by gravity. Black holes तो है ही. Black holes क्या कि मतलब even light cannot escape. वो हमने देखा. तो it is affected by gravity. It's not the case that like it will be able to travel everywhere. ठीक है. It's like that. This is true. Universe is constantly expanding. It is correct? Anyone having any doubt about it? Why it is the case? If I ask a question, why? Hubble's law. हाँ. Big Bang में Hubble has given a law that universe is expanding, and he has given a formula also related to this. This is right. Matter wraps its surrounding space-time. This is correct from Einstein's general theory of relativity. ठीक है. Basically, to understand all of it, last time when we started GS Foundation class, so we had, let's say, conducted 2 classes in open format, open mode. If you go through the second lecture, there are 2 lectures, first and second. Second lecture and first lecture, if you go through both the lectures, you will be able to answer all these things and you will be having the solid knowledge about it. ठीक है. ये ठीक है. So we have discussed all of it. तो ये जो है correct answer is option D in this case. Although आज के class में we did not cover, but previous 2 classes that are available on YouTube, there we have discussed all of it. We are going to discuss in further classes the basic principles associated with this. Now, ये भी मतलब like उन्हीं class से derived है, मतलब like related to those class. Which one of the following is the reason why astronomical distances are measured in light years? Astronomical distances मतलब distances between galaxies, stars, वो that distance is measured in terms of light years. जैसे मान लो कि if we have to measure the distance between New Delhi and Agra, how do we measure? किलोमीटर. न्यू दिल्ली जयपुर कितने किलोमीटर? न्यू दिल्ली कर्नाटका किलोमीटर. यहाँ पे हम ऐसे मेजर करते हैं ना. बट एस्ट्रोनॉमिकल डिस्टेंसेस जब हम मेजर करते हैं दे आर वेरी बिग यूनिट्स. ठीक है. सो द मेजरमेंट यूनिट भी बड़ा होगा. अगर मान लो इफ़ आई हैव टू मेजर द डिस्टेंस फ्रॉम हियर टू द गेट, मीटर, वी विल यूज मीटर. इट्स लाइक दैट. तो यहाँ पे लाइट ईयर में मेजर करते हैं. व्हाट इज लाइट ईयर? Light year, 1 light year is the distance covered by light in 1 year. How much distance does light cover in 1 year? I'll just take 1 minute. Okay. What is the speed of light? It is c 3 into 10 raised to power 8 meter per second. This many meter light travels in 1 second. What distance will light cover in 1 minute? It is, let's say 3 into 10 raised to power 8 into 60. 1 minute में कितने सेकंड होते हैं? 60. 1 आवर में कितना करेगा? ठीक है. ये जो यूनिट है मल्टीप्लाइड बाय 60, क्योंकि 1 घंटे में 60 मिनट्स होते हैं. 24 आवर में कितना करेगा? 24 आवर मतलब 1 डे. ये पूरा यूनिट मल्टीप्लाइड बाय 24. ठीक है. देन 24 आवर मतलब 1 डे. 365 डेज में कितना करेगा लाइट? ये पूरा जो है इंटू 365. वॉट एवर डिस्टेंस लाइट कवर्स इन 1 ईयर, दिस इज नोन एज 1 लाइट ईयर. ये जो है दिस इज नोन एज 1 लाइट ईयर. दिस इज नोन एज 1 लाइट ईयर. दिस मच डिस्टेंस इज कवर्ड बाय लाइट इन 1 ईयर. सो एस्ट्रोनॉमिकल डिस्टेंसेज आर मेजर्ड इन दिस टर्म. It's a very big unit. ठीक है. Now the question is कि which one of the following is the reason why astronomical distances are measured in light years? We have 4 options. He is saying light always let's say travels just Chirag, right? I'm writing CH code. ठीक है. Yes. आप answer दो, then I'll write code and later on I'll tell what is the right answer. Yes, madam? D. She is saying D. What's your name? आपका नाम? हाँ? डिम्पल. DI. देखो D D एकदम अपने नाम से ही लेना है. ओ हाँ. और any other option?
सर ऑप्शन 4 कंप्लीट नहीं है वरना वो सही होता है इसलिए
हाँ. इसलिए C है. Light always travels in a straight line. See, the thing is like here we need to understand that when we talk about astronomical distances, what astronomical distances? Astronomical distances means distances between galaxies, distances between stars, like that. वहाँ पे already vacuum होता है, पहले से ही vacuum होता है. तो क्योंकि vacuum होता है वहाँ पे speed of light same रहेगा, constant रहेगा. ठीक है, क्योंकि वो vacuum पहले से है तो speed of light same रहेगा. Now I will tell you why other options are not correct. When we talk about light always travels in a straight line, ये चीज़ हम पढ़ते हैं up to 10th standard. 9th 10th में जब हम रिफ्रैक्शन ये सब पढ़ते हैं तो उस टाइम पे बोलते हैं कि लाइट ट्रेवल्स इन ए स्ट्रेट लाइन, सो दैट लाइक वी कैन मेक द स्टूडेंट्स अंडरस्टैंड कि रिफ्लेक्शन होता क्या है. बट जनरली लाइट ट्रेवल्स इन द फॉर्म ऑफ वेव फ्रंट. क्या होता है? दे फॉर्म इन द फॉर्म ऑफ वेव्स. Light travels in the form of waves and they form primary and secondary wave front. ठीक है, primary and secondary wave front, and this is given by which Huygens principle of wave front. मतलब हाइजन ने बोला है कि मतलब एक जो light when it originates from a single point, it travels in all directions forming wave front, and first wave front is, let's say, like it acts as a wavelet for the secondary wave front, like that. So it travels in all directions, light. Okay, so that's why this is not correct. Gravity of stellar bodies does not change. Why it is not correct? Because stellar bodies matlab, let's say sun. Why gravity does not change? Gravity changes. With time it will change. Why? क्योंकि sun में nuclear reactions हो रहे, nuclear fusion reactions हो रहे, and since nuclear fusion reaction is happening, mass is getting converted into energy. That energy is radiating it in all directions. Slowly and gradually all mass will be consumed, and then it's going to collapse. Sun is going to collapse, and when sun will collapse, it will become a black hole. So the present black holes that we see, वो सारे black holes are those black holes that has run out of energy. Earlier they were massive stars. मतलब जो हमारा sun है, it is let's say one of the smallest star in Milky Way galaxy. ठीक है, लेकिन क्या है, दूसरे जो stars है, they are thousands, million of times larger, bigger as compared to sun. So what happens कि on sun, since all those reactions are happening, the mass is getting converted into energy and slowly, gradually it will collapse. जब वो collapse करता है, it will form a dense mass, and उस time पे क्या होगा, मतलब like its gravity will change, because gravity is a function of mass of a body generally. ठीक है, it's like that. D, A, option A, distances among stellar bodies does not change. This is wrong. It is the universe is expanding, and in fact कि मतलब like the galaxy which is far away from us is moving at a faster rate from us as compared to the galaxy which is nearest to us. मतलब जो galaxy हमसे बहुत दूर है वो हमसे दूर जा रहा है ज़्यादा स्पीड से as compared to galaxy which is near to us. It is also going away. Everything is going away because universe is expanding, right? And since universe is expanding, there is a thing which is known as a shift is happening. You might have heard about red shift, blue shift, ऐसा करके कुछ नहीं? Okay, we'll discuss about it. ठीक है? Is it understood this question? किसी को कोई doubt in this question? Now, हाँ, it will be part of, let's say, like next class when we discuss. ठीक है, it is Higgs boson and all, so it will be related to that. Now let us discuss about another topic. I think time हो गया है आज का. 7:30 हो गया क्या? और 7:40 कोई बात नहीं. So we will continue our discussion tomorrow. ठीक है. So today was basic sciences class. I mean as per the schedule. So it was basic sciences. So that's why I have thought of covering some physics related thing, physics and chemistry. ठीक है. But like what you need to do tomorrow, I'm going to share the material of it. After going home, revise from those materials, and it will be helpful in the exam because like you need to reproduce these ideas. ठीक है. You need to apply the things in this manner. Only then prelims is very simple provided you are able to apply. मतलब science and tech part. Science and tech part. Okay. So online people also, so that will be all from my side for the day. So today we are concluding our discussion. Tomorrow we are going to have another discussion. Tomorrow we'll discuss about biology. I mean like it's there in the syllabus as, today. Biotech, yeah, biology and biotechnology. And after then in the next class we will start with core topics. Okay. So koi question, any suggestion you want?
सर मिलना only 2 classes. हाँ सर classes थोड़ी क्या?
हाँ कितने 4 नहीं है
दो ही है सर इस वीक 2 है और फिर नेक्स्ट वीक 3 है बस.
actually today itself I noticed कि हाँ why they have kept it this way, maybe because they might have planned for Holi, लेकिन like institute I think it will be off on 25th 26th, लेकिन उन days में my class schedule is given. So that I am going to talk with the management and जैसा भी होगा they will notify. Anyhow tomorrow we will be having class and tomorrow we will clarify कि कितने classes होंगे. I am always ready to take extra class. I am going to take classes so that I cover most part of it with material and all. ठीक है.
Sir, how to read science and tech for only the notes or any material?
Read from the notes, I would say. See, like there is no dearth of material of science and technology in the market. A lot of material is there, but conceptual clarity does not come. Those materials are not made according to like you know in a uniform pattern. So conceptual clarity नहीं आता. That's why like we stay stuck. ठीक है, वो चीज़ है. But after you attend class, some conceptual clarity, some linkages will come. And मतलब I am going to give you material also. Using this material, try to solve previous year questions, try to solve test papers. जहाँ पे conceptual कहीं पे deficit लगता है, you discuss with me. ठीक है. You are free to read any material which is there. NCERTs काफ़ी सारे हैं. ठीक है. मतलब बायोलॉजी के तो 11th and 12th पढ़ना है. फिज़िक्स से रिलेटेड क्या है कि 12th का किसी को समझ में नहीं आएगा, 11th भी बहुत मुश्किल होता है. ठीक है. मतलब इट्स लाइक दैट. सो दैट्स व्हाई इन द क्लास आई डिस्कस द टॉपिक फ्रॉम बेसिक, देन आई टेक इट टू एडवांस लेवल सो दैट वो कॉन्टीन्यूटी थॉट में रहे. टुमारो विल डिस्कस अबाउट द सोर्सेस ऑल्सो. ठीक है. सो और कोई सजेशन? हाँ, ऑल गुड. ओके. सो विल सी यू टुमारो. Okay, thank you.